anything until it finds the header.
When I was in LA, I was working at an aerospace company, and so there were all kinds of weird things like Verilog, or like the Xilinx products and Petalinux and all of these weird bespoke embedded system development software environments, and the installs, they're designed for Linux, so you don't have any of the Mac OS or Windows installer stuff, but they're also supposed to be proprietary. So the install scripts just have these embedded binary files in them. I don't know if they were zip or some like weird proprietary format or some other crap. Which reminds me, LabVIEW, you can encrypt or lock the virtual instrument, the code files, and I think it uses MD5. And like the entire LabVIEW, I think it's the FPGA code that's locked, and it uses the same password for everything.
Admin 123, it's your one word.
Base license key file, just yes.
I grabbed that talk today, but I figured
So what you're saying is
we'll let this go a lot, but it gets there eventually. So I guess Peter has worked with like operational technology, like equipment, systems, infrastructure. So if you've got a laptop or a server or whatever, right? Like the IT person is responsible for that. You know who to go talk to is the IT person. But what if like the projector breaks, right? Well, it depends on the business. It might be Elia, it might be the IT person, it might be somebody else, it might be just whoever happens to be around at the time. Their job is to go fiddle the projector, make it work. But now you start getting the camera system. Okay, well that's kind of bolted in the wall. Maybe that's like fit buildings IT instead. But what about the lights? What about the HVAC? What about the fire suppression and the elevators and all that kind of stuff? So as you kind of keep going down that line, you start getting closer and closer to like health and life safety stuff as opposed to like your lights being on or your video working, right? So there's this kind of like middle muddy ground of control where everyone knows who manages laptops. Nobody really knows who manages the thermostat. Half the time it's the building, half the time the building is actually outsourcing that to another company. So typically what happens is your OEM, like your Siemens or Mitsubishi, whoever it is, they install the entire building's HVAC, right? They then sell you monitoring services. So they're actually like sitting in an office somewhere watching all your stuff and making sure your AC doesn't explode or things don't break. But how are they monitoring? Well, that's kind of what this talk is about, like how they go about doing that. So, when most people talk about operational technology, they mean like the water treatment plants, nuclear power, transmission, generation, all kind of heavy industry side, the factories that make chocolate bars, all that stuff. But there's this whole other range of OT stuff that is not quite that industrial, but it's very important to like life and safety and health, which is just kind of like building systems and things around that. So with these systems, they have terrible security. Like most of them don't have any kind of, the protocols they speak don't even have the concept of password interfaces. And so the only way you can really secure them is effectively to like put them in a box, don't let people touch it. So segmentation is basically how you go about segments, or how you go about protecting this equipment, because there's no way to really protect the device itself. I had a conversation earlier with someone in the defense industry, and they're saying, well, we want to know what vulnerabilities are. What was it? There's a thermostat controller and this other stuff have. I'm like, why do you want to know that? It's like, well, I want to know if someone can hack it. I'm like, they can hack it, don't worry about it. We want to do that. He's like, well, tell the IT people to install an update. Like, they're not going to do that. They're not going to install an update ever. They will never install an update. But they're not even legally allowed to install an update. Building issues people do that. IT can't touch it. So you have all these systems where like the people involved can't even touch the system that is in the building. You have a similar situation with hospitals and clinical equipment, where the consultant for the big company that provides the X-ray machine is the only person allowed to touch the X-ray machine from that perspective, and that's where it's running Windows XP stuff. So anyways, the long version of this is like, the solution to all these problems is segment. And segment means you put it on a network that nothing else can talk to, so for the good guys, and you keep the bad guys from ever getting on that network. Bad guys get on that network, you're hosed because there's no protection once you're there, right? And so I do a lot of work in like finding ways around this. So thinking about you can get a network split up in 5 pieces. Like we can show typically that like, no, you've really screwed it up. Like a really common example is get a laptop and you plug it into Ethernet, but you're also connected to the Wi-Fi. You're now becoming a bridge between those two things. Or if you have a printer at home, for example, and it's got Wi-Fi, you plug in Ethernet, it's now basically an access point. Your printer is also an access point. So that's basically how things get like this. So in the early days of my career, I thought like data centers were these like magical, pristine places, and I started doing contract work, like installing servers, like mid-90s. Then I realized it really looked like this. Just it was all nasty everywhere. It was like, this is pre-Red Bull, I guess, but There literally was a data center in San Antonio to go to where there's a freaking possum in it. It's still haunts me. And water on the floor and things like that. So in reality, especially for the equipment rooms that are not your fancy data center, not like your Broadway or whatever, but like the little shack in the middle of the field that runs like your local telcos pop or whatever, right? They look like this. They look like garbage. No one goes in there. It doesn't have AC. It's like just gross. Probably has rats running around. So when you talk to people about how they go about securing it, they talk about these great little guides. Effectively, the top layer, the enterprise outside stuff. This is the bad stuff. This is like, okay, IT is considered bad guys here. IT should never be able to touch this stuff at all. Like, the folks who run this stuff like intentionally defend against IT ever getting to it. They do not want them anywhere involved with it, which is why IT gets frustrated that they're responsible for patching it, but they can't patch it. So the next level down, you have the supervisory layer. This is like your servers, control centers, human interface device, a fancy word for a screen or a thing you can touch, anything that like interface with the person. And then you get down to building controllers, and these are like the smart devices that control the real hardware. And the one layer below all that, that's the things that actually make the lights go on and off, the power go, the power not go, the water, the fire suppression, all that kind of stuff like that. So if you can get to the supervisory layer, well, you already control everything else because those devices control everything downstream, right? So there really is only really one line in the sand here between the bad internet and the supervisory level, and anywhere else in this process you get into trouble really quick. So there's actually 3 different recommended types of segmentation for OT. You got Purdue levels, if you've ever heard that word. When they say enterprise, that just means everything else is not OT. That's your normal IT network. And then you've got ISA, EEC, 6443, then you have IIC. They're all basically the same. It's kind of like a DMZ sandwich. Where you put all your like really dangerous stuff at the very bottom that has 0 security and theoretically more security as you go up the chain. So that's
I have a dumb question. Why is it called DMZ?
demilitarized zone.
Yeah?
It's supposed to be like the gap between 2 security zones. So it's
And
like
things that go through are tightly controlled?
that's the idea. Like nothing goes there. Like it's the way you restrict access from A to B.
Okay.
But they call it DMZ because people are. I mean, this stuff ARPANET started off in the military, so I got military terms attached to it. So if you look at these guys, what they tell you to do is between all these level layer 5, 4, all the way down to level 0, they say, well, we need to have a firewall all the way down to supervisory control. And so you have a firewall, and you're supposed to like split it all up and segment it. The challenge, of course, is the firewalls themselves are often the problem. The firewalls are actually the easiest way. Sorry, 2024 Mandiant/Google did this report where the #1 way into systems that they investigated as part of the response was people breaking into Palo Alto firewalls. Which are the exact systems people are installing to protect against in the first place. Their management interfaces with things that are most exploitable. Fortinet is not any better. This is a great graph. These are the 4 most common vulnerabilities back in 2024 from the 2025 report. And it's Palo Alto, it's Avanti, twice, and then Fortinet and FortiClient, all that stuff. So these are companies who are selling all the protection gear, and the other ones who are actually getting popular, and that's just kind of the sign of the times. You know, these devices are supposed to be the firewalls, often they fail, but if your firewall's good, well then what, right? Hopefully you've got good segmentation. The challenge is like, everything on your network is a bridge, right? It's got 2 interfaces as a bridge. You have a MacBook and you look at your configure now, and like 28 interfaces out of the box before you touch anything else. The wireless link interface, the tunnels, all kinds of crap stuff. So, I mean, take a look, it's fun. There's just all kinds of weird shit in your interfaces. Again, every single thing with more than one network interface on it is basically a bridge. And you say, okay, great, well, it's a bridge, but it's not actually routing traffic. Well, it ends up they actually are also routing traffic. If you've ever installed like any kind of Docker container on your laptop, well, guess what it does? The very first thing is it turns on IP40. So you immediately turn your system into a router the second you enable any kind of containerization system on your laptop. So you're a router by default, just because you need that for the Docker container to route. So you use Kubernetes, OrbStack, Colima, Hotband, whatever. All those things basically turn your system into a router, unless you explicitly go set a firewall and block it. We did some work a while back about like which devices actually forward IP packets from one interface to another by default. Not just like are they multi-interface, but will they actually route a packet to be? Like you can plug in behind a router or behind a printer, can you actually target machines on the other side of the printer through it? And the answer is yes, basically all of it. IP cameras, thermostat, you know, image scanners, light switches, game consoles, even like a PS4 would route traffic from the Wi-Fi to the USB unit. Like everything is basically a router. So the challenge with that is like if everything's a router and you have like even one system that shouldn't be on the network is on the network, well, all your carefully controlled choke points and DMZs don't work. So this is like a network that's only like, I don't know, 40 employees, and it already has all the little red dots or internet points inside the network. Places where you go from outside in already. And of course, the more things you have, the bigger it gets, and eventually it just gets like, it turns into one giant pile of spaghetti really, really fast. So another type of device for a lot of fun for these things, kind of jumping what they call like air gap, or these out-of-band devices. So your IP KVMs, your Digi serial servers, your boxes. You know, these are basically how you go about managing a machine that otherwise you don't have physical access to. So typically you'll have like a very important server like running your HMI supervisor control, and then it's got a Dell iDRAC card in it. And then you hook up the management port, the Dell DRAC card to your enterprise network, because that's how you manage the damn server. But all it takes is, you know, attacker getting into the DRAC, to then rebooting the server, and do a rescue disk, and then take over the server. So effectively, if you take over the BMC or the KVM, you can almost always take over the devices connected to, and then sometimes vice versa. If you're able to compromise like a Dell server, you can reflash the DRAC card to the back door, now you're on the management network for the out-of-band stuff. So out-of-band systems are just a nightmare in terms of security, and they basically what people think of as their air gap between networks. So, Kim loves it. So fun tricks, this is kind of where it gets into like Go mode again. So I write a lot of protocol stacks in Go. So the most recent semi-recent one I did was IPMI, which is the protocol like your Dell DRAC, your HP ILO, your Supermicro IPMIs, Lenovo, XCC, all your out-of-band lights off protocols basically. They speak this thing called IPMI, which is normal. The really great thing about IPMI is that the way you authenticate to it is you say, hey, my username is X. It says, great, your password is this. Confirm. Okay. It didn't intend to hashes the password, but because the passwords are often default, you can crack it super fast on any GPU. You just basically decrypt it real quick. You can just brute force the hashing of that. So HP ILS, for example, ship with a default random long 9-digit password, which is supposed to be secure, and it's legal according to the state of California, which is a whole other thing. But you can take the rapid response from IPMI, throw it into Hashcat real quick. It'll crack a digit-only password in like 10 seconds, and you go log into the thing, and then you take over the rest of the HP server. And then you're taking over a machine with like, you know, a whole bunch of H200s on the internet, which is fun. So, what's funny about this is I went and like scanned the internet for fun. So I found about 14,000 DMCs on the internet with IPMI exposed. They all expose password hashes by default because the protocol requires it to send you the password. So the server sends the client the password hash, and then you say, yes, that's my password hash, confirm, which is incredibly broken, but a lot of fun for hacking things.
Which is still the standard? Like they haven't fixed it?
I mean, there's other protocols called Redfish now that's HTTP REST management, but if you are IPMI compliant, which every server still is out of the box, I think Dell iDRAC only finally started turning off IPMI by default in the most recent iDRAC 10, and then HP only started turning off in ILO 7. So unless you're buying like a super brand new server out of the box it's on, you can buy a brand new one, you turn it on because that's where your tools use. So if you want to manage a thing within the standard ISP tools, you have to turn it on anyways. This is how you do things like check the chassis temperatures remotely and things like that. If you're monitoring the health of all your equipment, you need to enable this stuff. And all this
They didn't patch like the old ones, or?
There's no patch, it's the protocol. Like, to speak the protocol, you must give the client the password hash. And so so what they've done is made stronger ciphers. So they say, well now it's SHA-256, like okay, but it's still an 8-digit number. Like, it doesn't really help. It may slow it down a little bit, but it doesn't really make an impact.
Does the protocol also specify like a maximum password complexity, or like?
I don't think so. It's probably, I think per device probably has a maximum, there's no built-in limit. It's not like it's like per block, like that. You could probably do a really long next one too. Yeah, I mean, if you have to use that in your mind, definitely use like a 60-character password. The challenge is some of the BMCs, you can dump the clear text password from the machine. Because the problem is the BMC has to be able to send a different hash for each cipher you ask it for. So by definition, the BMC has to store the password clear text, that way they can't do hashing. So if you dump the memory on the BMC, you get the whole thing. So you can fund attacks that way. So here's some stats, it's probably really tough to read. But the number of machines had an empty username and password admin was like 2100, and then all the way down. It's all your common stuff. And so this is fun ready and go, because the Go code actually auto brute forces password hashes too. So it asks the server for the hash, and then it looks at some common variants, and it tries to guess some passwords on the fly real quick, and just spits out hashes. So maybe a fun experiment with running a really clunky old protocol in Go, and then some fun results in terms of like hacking the world and stuff. So another fun way to get around networks is V6. So if you have, if you say I don't use IPv6, well you're wrong. Like your phone has a V6 address, your laptop has a V6 address, your TV's got a V6 address. So even if you have like, you've set IP tables up, do all that stuff, if you forget to do IP6 tables in addition to IP4 tables, your firewall doesn't count. People could just get into your link layer V6 address. So every machine typically has a V6 address on the default, and that's a way to basically bypass. If you have like systems with different IP networks on the same link and a firewall of IP, someone can basically go around that by talking to V6 address and link instead. What's weird about it is it's really hard to test that. Chrome, Safari, Firefox, there's no way for you to browse to a link local address in the browser you're up. Because it requires entering the FE80 blah 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 blah, but then :% sign you're interfacing. So literally the interface name is like %et0 or whatever like that. Has to be in the URL for it to resolve it, because link local is a preferred interface. And the browser vendor said, now we don't want to deal with that. So every link local v6 address out there, you actually can't talk to with a web browser. And so of course no one even thinks they exist anymore, but they're still there, they're still listening, right? You can still use curl to get to it.
Can you get to JavaScript or just not type it into the address?
JavaScript's fine too, like any network is fine, it's just the browser, the URL spec, they can never agree on how to encode the zone, the percent interface name, and so they just gave up, said, no, we're not gonna do it. So this is kind of the fun part. So getting back to like watch, dogs mode again. Have you ever played Watch Dogs, the game? It's fun. So the game I think starts off the first one that you're basically controlling traffic lights and generally like taking the entire city to get your mission. So like Grand Theft Auto with more nerdery, basically. So getting back to the building management stuff, these devices are not particularly secure, and they're all connected together. So if you can talk to one thermostat, typically you can actually make that thermostat then tell you connect to relay your connection to everything else on the same bus. So even if only one device is exposed, you can actually get to everything else in the same building. And the numbers get pretty crazy. So as far as I can tell, no one's actually built a BACnet sub-device scanner before now, or even like a PropNet or a KNXNet. So ended up building a bunch of Go tools that all they do is say, first go discover the protocol gateways, whatever, like HVAC, thermostat, or whatever, and then actually identify all the neighbors who are behind it, and then actually start routing packets to the neighbors behind it, and actually like enumerate them too. So it gets to the point where you can actually like see behind the device interfacing. And so it starts off being like, 4,500 devices exposed to the internet, ends up being like 100,000, and there's a kind of fun demo here in a sec. Again, this is all Go work. So the thing that's about these protocols, if you send the wrong packet, you destroy the device. You like brick things by sending the wrong data to it. So if you're trying to build something like a Modbus or BACnet enumeration tool, and you get like something wrong in your initial code, like you've just destroyed your entire customer's systems. They have to go physically, pull breakers and start the production line again, and cost millions of dollars, things like that. So how do you go about like building safe code for a protocol you can't talk to and you don't even have a device for half the time? So there's something called an Atlas Copco Open Protocol, which is used for rotary tools in car manufacturing. So every time that you tighten a bolt on a car, it actually records the VIN number that you're currently working on with the car for that bolt number. So later on, when something breaks, which bolt went to what car. So everybody who's making cars and putting bolts in, you're basically programming a VIN number into your rotary tool. The rotary tool is going to use and it's tracking which bolt from what car, what VIN number, and so on. But those tools are open on the network too, and you actually control them. And the only way to actually enumerate these devices is actually just talk to them, which is really scary because if you get it wrong, you're like, twisting a giant bolt around somewhere or breaking stuff. So I started working this Atlas Copco protocol. I found like one really ancient spec for it that like leaked or like paid for. Half of a Python implementation, and spent like 2 days building it. But this is a little bit of an AI talk in that sense. Like what worked really well was first using the spec doc to build a simulator, and then using a different LLM to build a client, and then cross-testing the crap out of them, and then testing them against any implementation you find. So finding like a commercial client GUI Windows tool for it, and making it talk to my simulator, and then same thing, having my simulator talk to their stuff, vice versa. So after going back and forth a million times and almost like didn't quite get to like formal methods, but like make sure like we will never do anything transition from state A to state B that would cause this tool to explode or do the wrong thing. So the LLM definitely made it easier to like brute force build a simulator and brute force build a client and then cross test the shit out of it to make sure that we were going to destroy a car factory when we deploy this thing. So that ended up working pretty well. I'm hoping to expose like open source all that stuff soon. And the same thing with like Ethernet, SIP, KNXNet, all the other ones. That being a whole bunch of manual work as well. So one quick pitch before I get into kind of quick demo and then code stuff. There's two new Go tools that came out recently. They're really cool. They're both from a company here in town called Praetorian. And one's called Nerva, which does a lot of what I do all day, which is like send weird crap on the network and get protocol responses. And they definitely like, vibe coded a lot of it, but it works pretty well. You've got about 250 protocols out of the box, including all the weird EDP shit that Anaptos do. So you can take Nerva, basically point it at any port, any server, anywhere, and it will go figure out what the hell it's talking, including like KNXNet and BACnet and all these other protocols. It only does the first part of the handshake, but it'll spit out like a CP identifier, like this software, this version, this vendor, or whatever. So a really, really great way, and it's all Apache licensed and easy to play with. So I'm working on a project now to take the ZMAP, ZGraph project, and Nerva and kind of smash them together, try to like at least make them use the same code base and share the same protocol stack, and then hopefully open source the rest of our stuff at work in the same stack. The second project, the same team that they put out recently called Brutus, and Brutus is basically a brute force tool. So you give it, it's all Go, you point it at a particular server, and you say, go test a bunch of passwords. But the neat thing about it is it wires up to Nerva and Navi, which is like the project discovery tool with the nuclei. So you kind of pipe Unix, pipe chain all these things together. And they solved a really, really annoying problem, which is a remote desktop protocol. You would think it's like, okay, we'll just go log in or whatever, but the entire protocol is done with glyph maps. So the server sends you a glyph map, but you don't really know what character stuff is. And when it's sending you little bits on the screen, it's telling you what index to bitmap to draw, and that's how you do text. So it's a huge pain in the ass to like write code to talk to the remote desktop protocol, because it has a billion stupid quirks as well as a stupid glyph map thing. The only code you can find for it on the internet is if you're like GPL3 or AGPL, like it hates its user so much. So what these folks did, which is really clever, is they found a Rust implementation of RDP called Iron RDP, which is actually pretty good. But it was a fucking Rust, right? So what are you gonna do? So they took the Rust code, compiled it to WASM, then shoved the WASM into Go, and and it actually works really, really well. So taking the Rust, output and running it in Go is actually a really good way to solve this problem. So they managed to build a really good RDP fuzzer/screen scraper in Rust in Go through WASM, and it's actually pretty cool. So I definitely recommend playing with both those projects if you're time for it. And then getting back into like kind of fun part here. Okay. Yeah, so I mentioned there's like, 4,300 APNIC controllers on the internet. These are things like random thermostats, crap like that. Nothing super exciting. And 4,500 out of 3.7 billion IPs is not that much. So it didn't really seem like a big deal. So then I went on and actually wrote all the code, went out the whole internet, scraped the whole thing for a couple days straight. I'll probably end up on like some Iranian watch list. I'm serious, like what happened is like there's the Iranian folks started hacking all the US infrastructure, and there were a whole alert went out to the FBI and everybody saying that they're trying to hack in through Ethernet IP and SIP, and I'm like, shit. I just Ethernet IP SIP repeatedly for 5 days straight during this period. So like if they find any IP in their logs, it's all me for the last 5 days straight behind my hand. So if I get taken away, what would happen? It was
And don't you risk being flagged by your ISP? Like all this?
Google never cares, it seems like. But
Oh, you go through GCP servers?
Oh, I just run it from home.
Google Fi.
Google Fi, okay.
Yeah, sorry, Google LSP. So I normally run it off like a DigitalOcean or whatever, just in case there's like testing scripts here and there, and I'm like, oh shit.
So like you ping the whole internet and they're fine with it? Okay, cool.
There are certain definitions of fine. One version of fine is they don't notice, because no one's looking.
It's not like they're robots spinning their service off to Stone Peak. So
There's a lot of honeypots out there too, which is kind of fun. Yeah, 4,000 Ethernet SIP and 4,500 backnet seems not that bad. Then we get to the fun part. So this is actually online. If you want to look at it, it's I'll drop the URL into our Slack channel after this stuff on top of this. So this is really stupid bytecoded crap. Effectively, the backend is all Go. It enumerates Ethernet SIP, backnet devices, and then it enumerates all the machines behind the devices too. So it's like not just like is your thermostat there, but what else is on the same building as the thermostat, and then we're actually messing with that too. So it's 6,000 routers, 55,000 backnet, in terms of about 101,000 sub devices. So it's kind of fun. You can do things like search for the police. And you pull up the police, then you can start. So you see the IP address of the actual backnet controller, and then you see all the devices behind the controller. So they have 41 devices inside the police station, and each one of these controls like lights, air conditioning. The RQs actually control locks, so these could be like release the prisoners or whatever, right? So like you can get full on, watchdogs here and just start opening up locks and messing with police and turning lights off and on, things like that. So it's crazy. So like a single device internet, there's 41 devices behind it in the same station. Here's a couple other fun ones, like some military armory. So this one you can see like, oh look, this one's faulted, and this is the mechanic room. Where is it? One of these you can basically have the toilet hooked up to it.
What does faulted mean in this context?
The device crashed.
Okay.
Yeah, one of these you can actually control the lights and the bathroom fans in some random military base. So that's fun. Yeah, you can search like boiler or whatever, and then you can find all the boilers on the internet and then start digging through them. Then you can dig through it all here.
This list is devices that are discoverable, not necessarily that you can manipulate them.
Well, you can talk to them directly.
You can talk to them?
Yeah, you have to go through the gateway device. You talk to the gateway device, but it relays all your backnet or your Ethernet SIP traffic to the real device.
Well, like are they just open? Like you can
basically,
Yeah, so
once you're in, port 23 is open almost always.
Yeah, these guys are all they're like oddball UDP ports, like 44018 or whatever. So like so this is 47,808. And so if you talk to this device, normally this should have been showed as one system. But if you actually do the work of enumerating all the crap behind it, and then you actually relay traffic to it, you can actually attack all 60 odd, 99 devices behind it. You can take over, one of our customers was testing this out at their school. It was like a K through 12. And they immediately went from like, oh, we only have like 10,000 assets to holy shit, you know, like another 4,000 extra devices, and it's all our building controls. And they're all network the students can get to. So, internal is even worse. External is pretty bad, but internal is insane. Yeah, so I'll drop a link to this little link. This is a quick little HTML quad output, but the whole output from it is driven by the Go code. Yeah, it's kind of fun. So I'll post some code in this stuff soon. We're trying to figure out how to like open source the Ethernet SIP and backnet code. There's already some code for backnet in Nerva and Gmat, but it doesn't do like the sub-device stuff yet. So we'll get that code and put it in the source soon. That's basically it. So thank you.
I'd be happier not knowing that.
It's a ridiculous how bad it is. Like, what's been haha funny stuff? Oh shit! Actually, like a couple hours later, I'm like, wait a minute.
Yeah.
Actually, it's just like the lights or whatever. You think that's bad? These are really it's like door controls, access control, fire alarm system. You can trigger the sprinklers. Like.
But why don't vendors harden things like out of the box? Like, why are defaults so open?
Where does it support it?
Yeah, the building management people are just sitting in their, office connection to that one IP, managing the entire building network. I mean, sometimes it is VPN, but oftentimes they don't. They just connect right to that IP that's on it.
But also, yeah, the hardware in many cases is physically incapable. They're often built to spec really, really cheaply. This isn't just building controls. This is a check-in desk at the airport.
And like I think the backnet and those are just some kind of serial communication. Those aren't. Yeah. So it's not like these are devices on the internet. There's a gateway. You talk through the gateway to this random serial protocol.
Yeah, they're supposed to remind behind the private network. Yeah.
There's a whole bunch of things firewalled off. It's on a serial bus, but it's actually through the gateway you can reach anyways.
And the serial bus has no authentication.
This is crazy.
So it's actually one internet.
Yeah. The scary thing about the serial bus is if you send packets too fast, you actually kill the entire bus. Because it's literally a 9600 baud serial port. And so if you send packets too quickly, literally the entire environmental control system stops working because you just basically use all the bandwidth from the serial bus.
Everyone passing the buck off to the next person. Each one of these things, their argument is, well, this is the wrong place, I think, to solve your security problems. Each person. Yeah, exactly. Yeah. Including the people who everybody else is pretty sure that they're the ones who should have taken care of it.
This means it's really easy to wreak havoc if you wanted to.
For that list, you could probably just run down the list and destroy everything in one shot and cause internet response and everything.
If you want to be really horrified, go to DEF CON, hang out at the Industrial Control System Village, and learn exactly how vulnerable stoplights and the power grid and water utilities and all of these other critical systems are.
Yeah.
I need to optimize my commute real quick.
What you said is you found all these things, and all of those things, if you talk the wrong protocol, they crash.
Yeah.
So you don't actually need an exploit. You just need to stop it.
You can just send the packet slightly faster and over buses. You can blow on them hard and then.
When they crash, they need a physical reset. Somebody needs to go in and
drive out to the field and hit a breaker on a device in place.
That's just because there was too many packets or the data was malformatted or something.
You put one byte in the wrong spot.
Okay.
So it's defense in depth, but the exact inverse.
Vulnerability on the surface.
Sleep tight, y'all.
My favorite bug of the whole thing is Ethernet SIP is the one used by power controls, PLCs in factories. So the little things that make levers go up and down, conveyor belts, and that kind of crap. So it's typically Ethernet IP/SIP, and it's not Ethernet or IP, it's UDP. They give it a stupid name. But the neat thing about protocols, when you're going through the gateway device, you say, I want to talk to device number 123 or port number 3 or whatever. I'm typically referring to a serial bus device. But all of this Ethernet IP controllers also let you specify IP address, and they don't even care if it's a local IP. So you can actually make the Ethernet SIP controller connect back out to the internet someplace else. And you can basically treat Ethernet SIP controllers as proxies. It's the worst proxy ever. But you can actually make them relay IP traffic, which
so you could just guess internal IPs and it will forward it without.
Yeah.
Fuck, okay.
You can just target internal machines that are not even Ethernet SIP at all, and start poking at them basically through the gateway controller. Because the devices will speak serial and Ethernet and a bunch of the protocols all at once. And so depending on how they're wired up, it's gonna go talk on bus 1 or talk on bus 2 or back plane 5 or whatever.
Okay. No authentication, no.
I did building management for 6 years. You're exactly right.
Well, we have BACnet SC now finally, so that is like the bidirectional TLS certificates to BACnet. So it's like all the same stuff, at least you've got client-side server. So
Yeah.
that's the new
I
one.
left before that.
Yeah. What I miss?
Crestron, Extron, AMX, video streaming to digital signage. You can put whatever images you want on any screen in this building.
Oh, in this building? Where?
I mean, like,
I mean, not these, but.
but they're probably secured, or if they're VLAN'd out, you can get through the VLAN using one of your bridge techniques. But then it's either RDP or some streaming technology to get there.
Which signs are you talking about? There's no signs here.
Like
No, like the room signs for the conference room.
the signage downstairs,
Yeah,
or
floor, yeah.
The elevator signs.
Probably the elevator
we're
signs.
controlling the power to these TVs using like the controller
Yeah,
on the
you can
wall.
control
I assume
power.
that ties to an Extron or an AMX somewhere.
Yeah. Yeah, like the content of these TVs, no, because there's more going on, but
Slightly smart.
yeah.
Or I guess what we don't.
Well,
right?
you just
Go
have,
through
you
Apple
just have to
TV
use
encryption.
different fun times to these.
So what you're saying is the S in IoT stands for security?
Yeah, yeah.
Well, it's Internet of Shit, right? That's the S.
There is more pizza back there. Please go kill the pizza. We don't want to take piles of pizza back tonight, so have that. And up next, we've got another interesting discussion. Discussion.
So this is not really a presentation. This is more of a maybe hopefully interesting problem. And let's see if my computer decides that it likes the network. I did update, so there's a chance that the drivers will actually like it.
Well, and I've got more adapters for you to try a different type of adapter, but I do not have.
The question is, does it recognize the actual resolution, or does it try to kick back to, I can't find the EDID, and I'm going to give up and give you an absolutely garbage resolution, like it normally does. Oh,
Is
okay.
it gonna blink every few seconds?
Huh?
Is it gonna blink every few seconds?
Probably not. So before, I updated the kernels, drivers, and all that crap. Before, it couldn't talk EDID. It couldn't figure out what the resolutions were, so it would just default to 680 by
640 by 40.
Yeah.
Well, this looks like still not native resolution because like there's nothing on the side, so you're not using the optimal.
Yeah, but it doesn't look like garbage.
It is a slightly less garbage tier of garbage, and that is acceptable.
Yeah, okay, this is a lot less garbage than if it was 640 by 40. No. So, I decided to build a distributed deterministic state machine because I used somebody else's code when I could write my own. The context is I decided it would be fun to build a game engine, build a PCS entity component system game engine. And I wanted to build my own multiplayer, I wanted lockstep deterministic multiplayer, but in the end, I'm trying to create a deterministic distributed state machine where you have different computers talking to each other, and they all exist, and they're all playing one game, and they're all running in lockstep. And lots of games, most games operate with some authoritative party. You have the server, and the server decides how the game's going to run, decides who's cheating, decides all that stuff. But that's not the kind of system I want to build. I want to build something where everybody is running the simulation in lockstep. So, it's a distributed deterministic state machine. Because if it's not deterministic, then different people see different things and it all goes down. That was the answer. So, my requirements, peer-to-peer, there's no authoritative party, there's no server that decides how things work. There's no server that says, okay, we're gonna tick, this is how things, pushing out the game state or whatever, everybody's evolving the game state in lockstep. Unreliable transport using UDP, because I'm a masochist / TCP has all kinds of fun limitations. It needs to be deterministic because if you're doing a simulation, if you're trying to do a lockstep simulation and you have any non-determinism, now you're not in lockstep anymore. You have desyncs and divergences. So, some of the problems, I want to have a lobby state where everybody is connecting and players joining and this kind of stuff, and so you need to transition from we are not currently executing the game simulation into we are now ticking the game simulation. And that transition process, because you have various different people, you have some set of peers, some connectivity diagram talking to each other. It's fun trying to make that happen. And I mean, there's a relatively straightforward solution. You have a two-phase commit, and you have everybody say, okay, I'm ready to transition, and then I've confirmed that everybody else is ready to transition. But yeah, so I think that's a fairly solved problem, but it's a complication. And the overall state machine is like, okay, well, we have this paused state, and then we are going through this two-phase commit thing, and then we are now executing the game, we're now ticking. It's UDP. Who the heck knows what order the packet's going to arrive in, whether the packets are going to arrive, what gets dropped. And then, it's a multiplayer game, so you have to have people able to join. And then if somebody drops off, you have to be able to handle that. If they time out, if they quit. And then, of course, my code's not going to be perfect, so there will be desyncs. There will be situations where some little bit of code was non-deterministic. I iterated over a map but forgot that map order was random, and oops, now they have different states. Now different players have different states, and there has to be some kind of process to recognize that and then do something with it.
No authority to declare consensus? How do you do it, like a quorum or something?
I mean, for the regular executing, for the just ticking through the game, tick 1, tick 2, tick 3, that's a fairly straightforward problem. You have to have a message from all of the players that says, I'm ready to execute tick 1, I'm ready to execute tick 2. When you receive all of those, you can execute them. And then you can say, every tick or every 10 ticks or whatever, you can say, here is a hash of the game state. And then once you receive those messages, if I'm sitting here on one of the computers and I receive a message where the game state for one of the peers differs, that hash differs from what I got, so that indicates that there's some kind of divergence in the simulation, effectively simulation. Then I can say, okay, well, I need to kick back into the other state.
But which state wins? Like usually we fix this with the quorum, like the majority wins. Like that's how Raft does it.
So it doesn't need to be.
Like if you have two groups, like there's a split brain scenario, and does state advance on both of them, or like how does it?
Basically, if you can't achieve consensus, you give up and go back. If you can't achieve complete consensus, unanimous consensus, you give up and go back.
Oh.
So before executing a tick, you have to have received a message
from everybody else
peer saying this is what I want to do, which would not work for it's not a general solution for distributed consensus problems, but in the case of a game, good enough.
So how do you handle peers timing out then, or desync?
Haven't written that code yet. I don't.
Yeah. Because I think this is like the biggest issue with distributed consensus. Like you need to keep the state moving if there is a non-majority that's disconnected or that disagrees. There's like split brain scenario.
I mean, my plan is basically if somebody times out and everybody else agrees that that person is gone, then they continue. And if you have a situation where, okay, these three all agree that somebody should be kicked out, but this one doesn't, then maybe those three just continue and this guy has to come back, gets kicked out and has to come back and join. But that's totally acceptable in a game. It's like, oh no, some player dropped their connection, they're gonna have to rejoin. It's
because there's no authoritative server, so there's no like leaderboard or fake internet points that you win.
Yeah.
You won the game.
Yeah. So if some weird stuff happens,
if.
So be it.
It's a pretty forgiving scenario. There's no money involved. There's no, fake internet points involved. It's just people playing the target kind of game is people playing a cooperative game. So if somebody gets kicked out of the game and has to rejoin, oops, move on. So the problem is, I want to have code where I can look at that code and understand what it's doing. I want a representation, so it's effectively we have the state machine. Effectively there's this complicated state machine where you have each party has its state, and then it also has a representation of what state it thinks every other party is in. So that it can make decisions about, okay, these people are actively participating. There's me and then there's the other players, and those other players are synchronized and they're actively participating. And then it has to update that state based on the messages it's getting back from them, and then deal with dropped packets and all that kind of stuff. And so I have a thing that works in certain subsets, mostly when you have, that works if everybody joins before we start the game. I have not dealt with somebody joining after the game starts running. But then there's these other problems, and I look at the code and I'm like, okay, this is entirely non-obvious. I can't look at this code and go, oh yes, I see what that's doing. It's like, okay, let me spend half an hour digging through this and building flowcharts and remembering it, like the your own code 6 months later kind of problem. If I come back to this after 6 months, I want to be able to look at it and not be completely lost. And my attempts so far have not worked very well. So I'm going to show some code. Any questions before that?
Have you thought about conflict-free data structure,
CRDTs, yeah.
What's CRDT is conflict-free? What's
That's what distributed MySQL uses?
Yeah, the acronym is CRDT, but I can't remember what
conflict-free replicated data.
Replicated, that's right. Yeah, correct.
So my vague understanding, I'm not using these either, but my vague understanding is that this is how Google Docs works?
Mm-hmm.
What was the team?
Type, data type.
No, I have not. I started writing this code and then went, oh wow, this is really complicated, I'm gonna have to figure something out, and then started looking up stuff.
So first of all, I am required to pitch the fact that the formal methods meetup is on the fourth Wednesday, and so I ran into that. And
I was curious if you have any experience with Alloy or
TLA Plus? Yeah, TLA Plus is probably the one you want to use for this. Alloy would be good, but TLA Plus is probably what you want to use. But that said, based off of the other parts of your requirements that you've outlined, I think Raft is the protocol you want.
That was a reason why I
Raft.
There's a YouTube video by the creator of Raft. It's sublime, like it's 40-50 minutes, and if you get into distributed state machines and distributed consensus, like it's really understandable and approachable.
If you're making something like this, which was like production and it needed to be super fast and everything like that, granted, there's a lot of people who are using Raft for that too, and that it can work. I think maybe Raft is possibly being overused in some places where it's not optimal, like where they're solving the wrong problem. They're like, oh, we need to have this easy to understand implementation of a distributed consensus protocol for a system that's developed by like 3 to 5 PhD level experts who probably, it doesn't matter if it's easy for them to understand. If they can reason about it formally, then maybe that's not actually a requirement they need to have. But in your case, that's specifically part of what you're going for, and that is what Raft is great at. Like it is a perfectly fine consensus protocol, not quite as fast as ones that are vastly more complicated, but it is way easier to wrap your head around. And what it kind of takes an approach of trying to keep an ongoing log of what's happening. And so that doesn't quite match the way you're looking at it, but it would be pretty easy to twist the problem that you have into one that fits very nicely in there. Where you treat the state as the thing being logged. And so that would work pretty well.
There's actually an amazing Golang implementation by HashiCorp. So they use it for their Vault thing and console and all that.
Vault is one of those places where I think that was a really stupid thing. But like, it's a well-made Raft implementation. I think that was the wrong choice for them. But
I mean, they have multiple Vault nodes that need to maintain the same state, so that's the rationale behind it.
Yes. Yeah, I can get into a long rant about why I think Raft is the wrong choice for that very specific thing.
Okay.
But Raft is a great protocol for a lot of stuff, just not that, and probably not for really large Kubernetes deployments. That is also what's underneath etcd.
etcd, yeah. And they use different implementation at etcd, like they have their own Raft implementation. They don't use HashiCorp's.
Yeah. They have their own Raft implementation, but there's also like, I don't actually know for certain, but I think it seems that from people I've talked to that the implication is that when you get to the actual big time cloud providers, they're not using Raft for their etcd. They are actually using the faster, more complicated algorithms because they have a room full of PhDs who are working on this. And so, you know, even if it's under certain circumstances only 10 to 15% faster for certain things, well, that's easily worth it when you're talking about a gigantic Kubernetes cluster. Like 10 to 15%, that's a lot. When you're talking about a game, and especially when you're talking about a game, and understanding what is happening is a high priority. Oh yeah, that is, like, Raft is a great choice for something like that.
There's actually a very interesting blog post about somebody, I think he was working for LinkedIn or some very big tech company. And he said like he tried pushing the number of nodes in a Kubernetes deployment to like 100,000 nodes or 1 million. And the bottleneck was basically etcd and Raft. So that's what he ended up switching and trying a different distributed data store basically.
Yeah, there are different, like, Raft is great for a lot of things, but it's not like the single best solution for every version of that problem, and so that's why you gotta be careful. You know, if you're doing something big at scale that's production, Raft might be the choice, or maybe something else would be. But for when you're looking at a system and understandability is actually a priority, Raft is probably the way to go. But you could do something like Alloy, but I think in this particular case, TLA Plus probably makes more sense analyzing whatever protocol you come up with. You can even look at Raft through TLA Plus if you want to see if it matches what you want, or if you would rather tweak the algorithm a little bit. You could, you know, since this is not like mission critical, like, oh, okay, maybe something works slower, or there's like a subtle bug, whatever. Like, it sounds like playing with the algorithm is a valuable thing to you in this case. And so starting with Raft and then pulling it apart and seeing what you can get it to do differently might be an interesting one. Or just start even with the simpler, the single Paxos, which is kind of the simplest one. It won't solve your problem. You know, single Paxos is not going to solve this problem. but if you did, it's normally just called Paxos, but to differentiate it between multi-Paxos, which that gets into a whole family of things. But Paxos, which we a lot of times call single Paxos, is simpler than Raft, but it's so much simpler than Raft, it's probably not even going to be useful for your problem. Raft is a pretty good choice for this thing, but again, like, part of the goal is to like play with it.
Yeah.
Oh, you should totally like take these, look at them in something like TLA Plus, and then go make your own and see what happens.
And I did look at Raft when I was starting it. In the absence of an unreliable network, like if I was using TCP, or if I could assume that I lived in a nice world where all the peers weren't trying to step on each other's feet, then the consensus problem is not that difficult.
Yeah.
Like the consensus for the game, like the basic state flow is not that complicated. It's dealing with the weird stuff.
Yes.
And the edge cases. And, the leader, there's some value in having the leader, but it doesn't necessarily, I don't feel that it necessarily solves the fundamental problem.
Yeah.
And I did look a little bit at Alloy and TLA, and my eyes glazed over and I had no idea what I was seeing.
Yeah, TLA Plus, so if you're gonna play with TLA Plus, I think especially, so the guy that created Paxos also created TLA Plus and LaTeX and all that. So there's a lot of, all these distributed protocols have implementations in TLA Plus because of that legacy or whatever. But
Who is it, Lamport? Or?
Lamport,
Lamport.
yeah, that's Lamport, yeah. But, if you need specific resources to make TLA Plus a little more approachable, I'll get you some information. There's a book by Hillel Wayne, even that's probably higher level than what you need. I mean, more advanced than what you need for this particular thing, but it's a good, more approachable starting point. It's Practical TLA, Practical TLA Plus by Hillel Wayne. But there's other ones. But yeah, that would be a good way to do it. We did a formal methods user group talk last year on Paxos. So if you're curious, it was in here in this room, so we did the recording and everything, so you can check that out as well.
Okay. Post a message.
Yeah.
Well, since I'm here, the code that I have today that mostly works, works in the simple cases. And there's a core event loop, and that event loop is iterating over a channel of commands. And then because I wanted to, so the idea is that the game, what I think of as a controller, like the actual game itself, calls next. And it says, I have a notion of intents. The idea is the player says, I want to jump, I want to act, I want to move or whatever. And then the game engine evaluates that. You click the arrow key, that gets turned into an intent, that gets turned into doing something inside of the simulation. And so I'm ready to execute tick N is I have transmitted my intents for tick N. So in the core loop, once the game's actually running, then the controller calls next for every tick. Says, this is what the player wants to do, give me the next tick, here's a set of things that happened. So there could just be one channel, but I use two channels to get easy blocking. So if somebody decides to go crazy and call next on two different go routines, which is a terrible idea, then they at least have consistent behavior. So fundamentally, the run loop is iterating over this channel of commands. And one of those commands is I got a message. Right. So there's here I want to do the next, I want next to return, I want to get the next set of events. So there's some simple logic, and this is one of the things logic about resuming and the state transitions is just kind of mashed throughout this big function. And so if there's an intent to resume, then it's time to start ticking. If we're ticking and you get intents, then those need to be wrapped up into a different structure, because doing game things should not happen when the game is not being simulated. And then, going to increment the tick counter, say we want this tick, register, shove some things into an array, into a map, or process them immediately, because there's the user intents, there's moving the keyboard, and then there's things like, I want to accept this feeder, I want to resume, unpause or whatever. And then send, there's a bunch of helper functions. So there's helper function to send to unblock the caller of next, so that they get the next list of events. broadcasting things, you know, saying, okay, well, we have intents, and we need to tell all the other peers what we're gonna do. We want to accept this new person, we want to have these keyboard inputs for the next game tick. And then if we got a command, we need to process that command, stop, pause, not sure pause actually works. If the local, if I'm an instance on a computer and I receive a new connection, then I say, okay, and this is partially one of the things I like doing in concurrent code, which is you have a go routine and you have a channel that you throw things at that go routine through. Because now you don't have to worry about concurrency because all the things are happening in this one go routine. So, new connection comes in, there's handshaking and connection management and all that kind of stuff, but that's a separate concern. Then the engine needs to know, well, some part of it needs to know, hey, we got a new person, somebody connected. So we say, hey, look, we got a new connection, inform the local game controller, somebody new showed up. And maybe maybe the UI wants to pop a new person, put a little, hey, Ethan connected to your game or whatever. And then broadcast a packet to everybody else saying, hey, we got a new peer. So if you want to connect the mesh and not have a star diagram, then there would need to be some kind of address information, which I have not dealt with yet. If we receive some other message, then okay, we need to say, hey, we got a message from this peer, process that message. There's the handshake stuff, which is irrelevant at this phase, which those messages should not go through, but I'd rather not have things crash because some message got through to a channel that I didn't expect it to. So those get dropped, and then we have, hey, we got a new peer, okay, great, register them, add them to the map. We received a message from the other person saying we have intents, and then, okay, we're done processing all that, so maybe we want to, maybe somebody called, if somebody called next, we need to do something. If we just got a new message, if there's no one blocked on give me the next tick or the next set of events, then great, just go back and wait for more stuff to happen. But if we want a new tick, then and this is to handle the lobby, because in the lobby state things are asynchronous. Doesn't need to be lockstep because we're not doing anything, we're not simulating anything yet.
Why not? Why not simulate a lobby with people coming in?
Because that makes things more complicated, because everybody has to agree what number the next tick is. When you say, here are the things I want to do on tick N, that tick N, everybody needs to agree, everybody needs to have their clocks aligned. If the clock starts when the game starts. So the way I have it set up is that clock doesn't start until everybody says I'm ready to play now. If that clock starts immediately, then part of that handshake has to be synchronizing the clock. And that's a problem I didn't want to deal with. So,
do you actually have the ticks have numbers?
Yes. And the idea is, if ticks have numbers, then saying, then everybody's okay, I'm executing tick 1, I'm executing tick 2, I'm executing tick 3, and the synchronization, there's a very clear boundary, there's a very easy boundary. I can execute tick 3 if I have received the I'm ready to execute tick 3 message, the intents from every other peer. And I can also use gossiping, and I can also take those intents, and if there's some packet dropped, if there's some incomplete connection between peers, I can take, Alice can take Bob's intents and tack that onto her message when she sends those intents to Charlie, and I can gossip those messages around, and if everybody agrees on which tick number this is, then that's a very clear boundary condition.
Yeah, but people in a lobby seems like a really simple game, and we should just play the people in a lobby game. Couldn't you just have a not game where you advance to the next tick by not doing anything?
Yes.
But actually that is a following question. Like, the game seems like it's in the engine here. Like, maybe I'm not understanding, but it feels like you have a layering violation.
So, if I have,
Rather than just, like, your engine should be just a consensus protocol, right? And then the game is, I wanna change things.
so the intended usage is, you know, I have some, I start up, the game says, the game itself, you know, the actual application says, hey, great, start a new signer, listen on UDP, here's my key, here's the, you know, here's some UDP address that I wanna listen on for incoming socket, or, packets. And I don't entirely remember what UDP does. Do we just have to hang out and let that sit around? Yeah, okay, so you can explicitly connect, but mostly that's just a thing that just hangs out. So unless you have somebody you explicitly wanna connect to, you just say, okay, I'm gonna listen on UDP. And then the core game loop, you know, this is in some method or whatever, but the core game loop is, you just keep on calling next.
And then you do cards or jumps or whatever is in the actual game.
So the game just decides, yeah, the game is going to decide what the game is doing with those intents. So that one is a remote one to my other, no, what crap, what am I doing? Nope, that is not what I was doing. So if I actually wanted to show anything, then it has to be local. Let's see if that works. Maybe. So as I'm moving the keyboard around, what's happening here is I'm taking the inputs, where is that code? Update, okay, so update, doing some stuff to read the inputs from Evid Engine, processing things like escape, quit, and then there's the actual game tick. So this is the ECS here. And you say, I want to tick, the tick is however long, whatever time dot duration, or actually that's a floating point, that's a fixed point number, because apparently IEEE 754 implementations, floating point implementations, can differ between like Intel and AMD, or definitely between x86 and ARM, and then you can get non-determinism and desync because there's subtle little differences in the floating point, and no.
So have you thought about with the problem back on its head, instead of sending an intent to everybody else, process your intent locally to the next state and then trying to ask if everybody else will accept that? Because if you think about that process, there's a very widely existed system already does so, which is blockchain. Because you calculate what you're actually going to produce, try to attempt everybody to accept your post-action state. If everybody is willing to accept that state, then everybody just simply update the state. You don't have to worry about synchronization because there's no need for synchronization because the state has already been calculated. Everybody simply accept your state. If anybody want to do something else, it figure out whether it's happened before your state or after your state, and then it may try to attempt to reject your state or accept your state. Then that entire process would just be a blockchain problem.
I mean, effectively, the intents are the transactions.
Right. So instead of asking everybody, would you accept, pre-compute said, assume everybody accepted unless the majority, or unless they reject it.
Effectively, what you're talking about is statement-based versus row-based replication.
Right.
And you know, you've seen, for reliability purposes and that sort of thing, folks switching to row-based replication on databases. But, you know, if you're dealing with, you know, simultaneous actions in the game, then maybe, if you're just going to wind up with conflicts literally every time, then that's not an option.
But the blockchain already have a pretty solution to that. Whoever has the longest chain prevails. Then whoever basically.
Right, but if it's turn-based, then everybody for any given, you know, turn number is gonna have the same length of chain. You don't have a clear consensus there.
I'm not sure that it maps directly, because I mean, one of the issues is, you know, if I have various players involved, and, you know, everybody's sitting there, like if we're playing a game, I don't know if you're familiar with like Terraria, where there's, you know, if you're fighting a boss, there's a whole bunch of people, you're gonna have constant keyboard inputs. So you're gonna have people constantly saying, I wanna do a thing, and if you drop a packet, if packets are getting dropped, or if the timing is such that not everybody agrees on which tick, well, I mean, I guess potentially, depending on how the engine worked, depending on how the actual game simulation worked, there might be a way to make that work, but that's a much more, like,
So
deciding whether or not this series of inputs, if they're received in different orders, leads to a different overall game state. That is a much more complicated system, because this is effectively a simulation.
right, but if you think about it, if you want a strictly deterministic state, that means you can have one and only one sequence of event. That is literally what blockchain does.
Yeah, again, I've not used it, but supposedly CRDT is, but you have no conflicts.
Okay.
I don't know.
Yeah,
I'll look at it.
Yeah, again, this is like the big multiplayer game, which is Google Docs, where 15 people can edit all at the same time, is apparently built on CRDTs.
Well,
And if you think in your case of like multiple input, for example, two people try to press the same button at the same time, one of them still, it doesn't matter whether they are actually simultaneous input.
but that's not the
One
problem.
of them have to happen in terms of a state calculation before the other, because there is, one of them could be, because unless you're willing to accept multiple input state transition, one of them going to happen first, the other one going to happen next. So it's going to be a sequence of event. So if one chain, calculate it, input one happened, the other chain thinks input two happened, well, they're going to have certain conflict, but at the end of the day, one of them going to happen before the other. So let's say that at the end of the day, button one supposedly happened, so button two will be rejected and recalculated. What happened if button two get pressed after button one? Because the sequence of event of button two pressed first is no longer valid, so that chain gets discarded and recalculated.
But if we have three different players, if we have three different parties and they all disagree what action got executed, then what, are we just gonna roll it back and keep on trying until at least two of them agree?
I mean, that's how the blockchain Bitcoin
Yeah.
works.
Well, that's not necessarily the same goals of this particular game.
And I don't wanna be executing 50 times a second.
Well, right, but it's highly unlikely you're gonna stuck in that loop for a long period.
What's
What's
the blockchain transactions per second currently?
I don't know. I haven't
And
checked
how many of those are
lately.
rejected?
A lot. But
So
again,
it's-
but you also think about how many nodes in the world are in that
Yeah,
loop.
it's
right?
just a matter of, are you, what is the problem that's trying to be solved? Cause that's certainly a very interesting approach to its problem, but I don't think it's the same problem. You could use it to solve this, you could use it to solve this problem, but I think that's overkill
And
Well,
I mean, I think ultimately, even if I did decide that time was moving during the lobby, then I think solving that clock synchronization issue is not as hard as solving the frequently going to have diverging histories.
Yeah.
Blockchain, you don't need to solve the clock synchronization problem at all, because you only have to solve the sequencing problem.
Right.
Yes,
You
but
don't
my point is that A or
Yes.
B.
You're right, but.
And I think A is easier. I think synchronizing the clocks
Like,
between five
NTP
parties.
exists.
Well, yeah, but that is a constant moving problem while you're saying, when you're idle, you still have to keep your clock synchronized, as where if you're idle in blockchain, you don't have to constantly talk back and forth.
It's not
until
literally a
there's
clock
change.
though. It's just a number. We all agree we're on tick N. So as soon as we get synchronized, past that point in time with the current design, it's not going desynchronize. I mean, you can have a situation where somebody stops talking and, you know, okay, it stalls because they're not talking anymore, we're not receiving packets. Then you need to have some timeout. You need to have some logic for saying, okay, we haven't gotten a packet from this person for a second, we're gonna kick them. But once you have established that number, because it's just an integer, it's just a tick number, once you've established we all agree that we're on tick N, from that point forward, barring network drops, there's no disagreement, there's no desync, and the barrier for are we ready to go to the next one is a very simple question to answer. And so the only complicated part there's two main complicated parts. There's timeouts and then there's that initial synchronization. And I don't think that initial synchronization is that difficult of a problem. I just decided that I wanted to do it differently. And maybe that was the wrong choice. Maybe I should do that clock synchronization. Maybe that would make everything simpler.
Clock synchronization as a game sounds interesting to me,
And again, it's just, you know, integer synchronization. It's just
Yeah,
we
yeah.
all agree which number. And, you know, that could be something as simple as, if a new peer connects and we agree that, okay, we're accepting this new peer, then we say whoever has the highest tick number wins. And now we're synchronized. Who was asking about the game loop and how those things were organized? Well, anyways, so I mean, this is the basic loop. You start the game, you listen on a socket, you call next, and then if next emits we need to tick things, then you have your world, and you say, okay, I wanna tick the world for some duration. And the intents are converted into ECS components, and then you tick. So the game itself is controlling when next is called, and then it's controlling when the game is ticked. So it's kind of plumbing those two things together. So the multiplayer engine is just a communication tool and synchronizing on these boundaries. It's not responsible for how the game itself actually runs. And in terms of how things are executed, the intents just get shoved into the column store, and then the game is responsible for doing whatever it wants to do. So when I'm playing Pong or when I'm doing something and jumping around, all of those inputs, any of those inputs that my computer says happened in this 60th of a second or 50th of a second or whatever it is, get shoved in into the column store as components for the player entity. And then the game logic is responsible. So there's not, in a given tick, there's not a definite ordering for how it's not process this button, process that button, process the other button. It's convert these into I intend to move, and then the movement system runs before the punch person system. And the movement system says player 1 wants to move, player 2 wants to move, and it processes those. And currently it's just processing them in order of the entity ID, which just means whichever one got created first. Any other questions? Well, hopefully that was at least interesting. Got some stuff to look up. Okay, thank you.
To remind folks, we have got parking passes up here, that's what I was up here, kind of looking around, sniffing around a bit. We've got parking passes up here. If you parked here, I strongly recommend you use one of these. We'll take it from being like a $50 parking pass, parking ticket to an $8 one. So definitely would recommend this. Let's see, yeah, once again, thanks to Station Austin for hosting us for free here. And let's see, do we have any big Go events coming up? GopherCon's gonna be in like August, right? So.
It's gonna be concurrent with DEF CON.
Oh, that sucks.
You
Okay.
can fly from Seattle to Vegas if you wanna go to both.
Yeah, yeah. There's the year where it was GopherCon and DEF CON and Texas Linux Fest all at the same time. But not this year at least. Yeah, I think that may be it for now. As always, if folks have got ideas for talks that you would like to give, reach out to HD Uri. We'd be happy to help. If you've never given a talk before, we've got a lot of experience having given talks to a lot of different groups over the years. We've got a couple ideas for things coming down the pipe. I still would like to see some. I've got some ideas for more in-depth WebAssembly Go talks, but it's just going to have to depend on time and everything to see if that comes together anytime soon. Let's see, other than that, there's a few other things that are maybes on the horizon, but nothing definitive enough. So if we've got folks who are chomping at the bit for speaking in May, let us know. We've got a couple things lined up, but if somebody's got something they're pretty excited about, you might bump the next option down. Is there anything else? I can't think of anything else. Yeah, thanks for coming out, and hope to see you soon. Oh, and we've got some more pizza back there. Get rid of it. Or take it home. I don't care. Either one of those. Okay, yeah. Yeah. Okay. So, formal methods
and they had like a 527 from
techniques
and I tried to use like my router,
which are used
basically that you are
mathematical logic
to
thinking
your normal like
program
24
create things like program groups and
so I set those things like
commodities like
it was working locally, but I wasn't getting any
security,
packets from the
reliability.
So then it occurred to me, like, I didn't actually set the IP forwarding, like the settings, right? So because it wasn't actually forwarding the packet. So I'm like, how do you think this? Yes, that was like, that was kind of like, I was like, crossed my mind when I walked in. So I basically just use that. That's like that's hilarious. Yeah, very. Yeah, so they sent me a badge, and like that's the badge. Where they actually decided, right? But at the time I moved, I didn't have the.
I was looking for a while, and then there was COVID / my job time out my entire
I know, right?
at some point in time, yeah.
So,
Yeah.
I think apparently that's not.
so
Because it
a
was so
lot
hard,
more
like, that's the hard.
stuff
So
happened.
like, I got to like
That was hilarious.
Yeah,
very.
I think it was something like, I think if I made her set,
I have said that this before.
Kind of a different beast.
then I think like
There. Yes, yeah, representative.
Yeah.
Is that what they were talking about earlier?
I had the time and the time sealed, and I have a pre-order in for the.
Oh, yes.
Go.net, if you go to the community page, I'm pretty sure that's
There's
right.
one, just make my keep here.
Yeah.
the University of Texas, ACLU.
I found out the hard way that
So-
you like software.
What?
Yes,
Yeah,
Oh,
but
okay.
Instead of going to
there are
the-
also
that
PDFs.
exam.
So
Okay.
I don't know,
I
ATX, some of
They're
those
like,
comments
oh,
are-
they're back, yes,
But
it's
that
hard
part,
to
yeah.
buy
So
that now.
I think I probably have.
And
a
so,
little-
what,
you can ring my doorbell.
Yeah. We're neighbors.
Oh, nice.
Like right next door, and so I was like, I wasn't 100%
Isabel
sure.
and,
I thought you were meaning for the hack.
No. No, literally live next door to
We're all neighbors,
You've
obviously.
got,
He probably, yeah, there you go.
Because the two main ones that are still
We might be able to
moving
ring
around these days.
We
Are,
have
ACLU
a Nest doorbell that's not wired up to anything,
Oh,
so if
okay.
you ring it, it doesn't. Well, unless I remember to replace our batteries every so often. It's actually really, can be kind of convenient, because like, I think most of the time, if someone rings my doorbell, it's a solicitor, and so it's like, I don't even have to deal with like the social anxiety of like, where should I go?
No soliciting signs are legally
Basically
binding.
trying to
Oh,
say,
interesting.
They're not allowed to ring your doorbell if you have a
computer
we
programs.
We got so
in
many
Untitled
Yeah.
random people, I'm like, no,
So
I'm not interested in that.
it's more, usually
No, no
the.
soliciting sign?
the,
Works great.
Oh, it works for, yeah,
Yes.
okay,
that
that's
you
perfect.
use
The
for
only
type
time I
system
had to
for
talk
your
to somebody
programming
is
language
when
rather than the programming language
the
itself.
dog barks and I don't know why.
Uh-huh.
That
I
is
open the door
equivalent
and there they
to,
are. They haven't rung the doorbell.
Uh-huh.
And then they give me the pitch.
But
Mhm.
basically.
Is there a way?
Normal way.
No, like they walked
It's
up,
just
saw the
like-
signs,
yeah.
and my dog heard them. The
Mhm.
dog barks,
So
and I
it's
happen to
interesting
be there. I'm like, what's this noise?
You
And I
can
open the door,
analyze,
and then they do the whole
the
pitch.
nature of a
That's
program
why I
language
have my street
as if it
supply
was a
is
mathematical
dried up.
construct.
Oh, yeah?
And vice
And
versa.
my front door
You can
is
turn
just
very
glass with frosting
complicated,
on it. So
uh,
I walk down the
mathematical
stairs, I just sort of
constructs into programming
stare at
language
them as they
and
ring the doorbell and be like,
code.
no, I'm not gonna touch you, I'm home, you saw my car. What's wrong with you?"
Well,
Yeah. But yeah, apparently you put up a sign and like, they're not allowed.
I have a neighbor friend who has the sign, I always forget to ask him, like, does it work, but I didn't know it was like, we're lying.
Apparently, it seems to work pretty well.
Yeah, alright, that's good, yeah.
So yeah, godev.com, on the community menu, there's a Slack link.
There is one that is,
Oh,
that is
go
like,
for whatever the hell it is.
a
Now
403
you go
response
to-
thing.
okay.
Mhm.
But there's one that's like, nobody's home. It just goes to the abyss.
Well, so I think, so 404, I think that's the Nginx, internal code that drops the connection.
Is that the
So
one? Yeah.
it doesn't actually send any response, right? So because basically, I forgot if it drops it in free connection or not, but like normally like HTTP requests are supposed to come with a response, right?
Yeah.
So it doesn't, it just drops the connection.
Yep.
Of the recordings
Yeah.
we've done.
I did
Wait,
that.
so how is there a response code?
Some of the
There's no
recordings
response.
have
It just drops the
audio.
connection.
Great,
But why is there?
your.
There
Well,
was no
because
login
you still
for
need, you still need to, have it internally, right? So you basically,
Yeah.
like Nginx, it has like the code that it returns internally.
It has got.
So you say, like, for example, in the config file, in the location, you say return 444,
We
right?
will see.
And basically that's like the
But
internal
we
thing
can
that
show.
drops the connection.
Cause they can see when you do a 403 at them or whatever else.
Yeah, the 403, like, it actually returns that 403 to bit, but if you do 404, it just like drops it.
Is this not just stuff?
Yeah.
Okay.
Most of the people
402.
working on that.
Dude.
$4.99 is
Military
the
or
client
government
side
or whatever.
code that you get when the connection just
It's
went
not
away.
the best paying job
That's
ever.
not-
Oh, no, sorry, that's what you get.
No, I don't think you get any client
That's what
side.
you get on the
Yeah.
server side when the
And so,
client went away.
That
That
said,
was weird.
there are exceptions.
Yeah, I've
So
tried
it's one of the things that
I've
was
spent
interesting
time trying to
years
map
ago,
error codes to HTTP codes
AWS
and
had
then
a,
quickly decided that that was just
like a mass
Oh, yeah.
object or
a
something.
path to
Yeah, I was about to say,
Doing
that
it.
sounds like a really complicated way to
And he
work
wanted
with
to
Whose line is it anyway?
use TLA
Lays
plus
it up
what we
and
were talking
then
earlier,
builds stuff
to
out.
do some analysis of the way that one of the pieces of.
He says that non-standard code 444 closes a connection without sending a response header.
2008 or, I don't know, maybe 2010 or something, I don't know. It was
That's
a
what,
while ago.
that's what GCP does,
And,
if you try to connect to a sanctioned country.
What was
Oh, really?
interesting is after he did
Well, I
that,
have to
they
be
found a
on
bunch
the,
of bugs that
bit about
we
Java
redesigned
kind of
some of
stuff,
the
and,
code there. And they
the
deployed it. And
standing
okay.
protocol is if they come from
Well,
a place
they
you're not
were
allowed to
not
talk
getting
to, well,
correct
you're not allowed to talk to them,
bugs.
shut it off, walk away.
After he
Can't
had
send a response.
They were a little bit weirded out because they know
The
how
worst
many bugs
was
to
when
expect
Berksner
for
in
a piece
Germany
of software when it's
acquired
running
an
out there in
IP bank and
production.
didn't go
For
through
some
needful
given
to
language.
clarify
The
it's
number of
not
bugs
theirs,
in this software
and
is a
all their
lot
clients were getting
lower
dropped
than it was
worldwide
supposed to be.
because they thought all their
And
clients
so
were
they're
from
like, okay, let's try this again.
not
So
good
they-
place.
they
What was
shifted it
the
around.
country of the
Hey.
clients they were?
I mean,
Well,
it's
come on
basically,
in.
it's basically gonna be like, some,
So,
a couple of places in the Middle
they,
East, or, Cuba.
They found way fewer bugs than they were expecting.
This IP form
So
like
they
kids
were like, okay,
Wait,
well,
who
let's
did he belong to before us together?
I think it was some,
No
company in the
longer
Middle East.
interns, just
Oh.
people on.
Oh, like Iranian company?
Yeah,
Play with it a little bit
it,
of
like,
knowledge or whatever.
there are
Try
very
to-
few countries in the world where the
Another part of
sanctions
that.
that strong that
All the bugs
Google's
that
like
one went
public
away.
cloud would be like, nope.
And so then all of a sudden, Amazon was like, alright, it's on.
Also,
So
the
they
George
made
Forky
the
got
choice
sued
of
garbage and
hiring
stuff.
as many,
My email sending
formal
over
methods experts
365
as they
gov
could.
high
Yes.
security.
Turns out most of those are
Awful
professors
place
at
to be.
universities.
They don't
who are
believe
teaching
in
the people that
convenience
some of them
or
don't make
plugins or
military
anything that
equipment
can make
for
it less
NASA,
easier because that's
I had an idea
insecure.
for a game, and I wrote a game engine.
I do all.
Because.
But plugins are
there's a
great.
lot
Problem,
more
so
than doing
at the moment,
anything
there
normal
is like
basic.
aren't enough
This is the
professors.
problem.
Once upon a time,
We are back in
I had
2 minutes.
plugins in Slack that would give you the 1 minute notifications to mute.
I figured it out, and then I
Then
made
that was
terrible
on,
ideas.
I did their game, and all of a sudden our entire division was now late to our duties because we all depended on it.
Semester project or something, which was.
Any software that
This
is.
is, you're on the
highly
client side,
specific
using
another
Outlook for this.
Giant single
I
waterfall
work for a small
writing
ERP
in Java,
company,
these
we use
institutions, all the
on-premise
things
installations,
for Monopoly.
high security.
And then within the actual Monopoly, it all had like.
None of your email plugins work.
Like it was all computer
Yep.
players.
That was
It would
about
operate
one
statistics.
So this,
They
yeah,
no longer
this
have
is
their
Earth
own
365, which is of course on the cloud, on Gov High Cloud. But if you try to log in
that was
inside of
one
corporate
CS degree. I went
VPN,
to a.
it'll acknowledge the login
My
and
graduating
say,
class was
you can't do
They
it.
no longer have
Capital
If
College.
you're inside the
And there used to be a military radio training.
What?
if you're inside the VPN,
Because I went to
if
a
you're
college,
interested
my
in
degree was like
Yeah, if you're
90%
inside the
RF.
trusted network, you can do it. So you have to
But
be
yeah,
from
CS
inside the
classes
trusted
were-
network to
they
log
really
into the
like
government
that
cloud
much.
instance.
Left a little bit to be
I
desired.
think it was one of those,
So
they
maybe
don't
it's
mind
like
the
either
fact
time
that
you're looking at your
they don't like the
on-prem
fact
server
that
just needs
it
to be on the
1800
right network.
students in East Texas.
and so
Maybe, but
That was
government cloud
apparently
files has a
military
lot of
high
knowledge.
POW
It's basically when you
hospital.
ask like, Slack
Yep.
plugin?
trying to convince
No.
All of that.
Hey,
gone
can
away
we
with
fix
that.
the problem where the Zoom plugin sometimes doesn't work? We'll get to it.
I have not
Yeah.
succeeded yet, but apparently
2.5
they are
professors
so aware of us
Yeah,
and
the
see
engineering
that, like, you know,
stuff
maybe
was
it's
fairly
better
solid. The CS
This is
was
AWS.
the software industry know how to
Yeah.
do
not
this, so.
that.
We technically
We
have
had operating
teams
systems
today, we
class.
still have our legacy
Whatever
stuff.
stuff.
I have operating
All of our automation.
Literally.
and
It was their kind of view.
We would have an assignment
It
to
would
write
cost
all
a
of
Java
the-
simulator
the
to
weird
pretend
better
to
large
be,
system.
like, man,
But how
Google
does-
pretend to be
There's an
a
interesting
process
job.
scheduler.
We figured that out. Anytime custom board solve the
And it
problem,
wasn't like
it's
a
solved.
real, it was basically write a toy Java program that prints stuff to the
Alright.
console, pretending like you're simulating a memory, a virtual memory.
Yes.
All of it.
All of
To go
all of the
work
above.
for them
For
in
context, it's
Microsoft Research,
RTX Corporation.
which is
My
just
repository
Microsoft.
teacher.
And I went way dangling down the
is
bottom.
Harvard degree. And because the old math teacher
So, yeah,
has surprised
even though
me
it's strictly commercial,
and begged him and begged him and begged him,
applied
he came
the
back
federal
for two of the
regulations to the
classes
entire
for one
company
semester and they were
because
still half
corporations
free.
have to
They
all
did
the
do
guys
their due
made
diligence,
it.
hired this guy,
To
even
like
though
all
the class
the-
looks like paintball.
It is.
We started looking
that was
at
the
segmenting
whole
our
point.
business, we're like,
My
you're gonna be
favorite
FedRAMP, you're
class
gonna be
was
CNC,
actually
and
favorite
you're
class
gonna be
was the
SOC
professor
2.
who said,
They've been doing it
don't-
forever.
no.
Mostly as
Yeah,
like.
it's interesting though, because they want to show
Don't,
the
do
Yeah,
not
it's
fancy
not-
stuff,
they're not
don't be
using
fancy,
not
just
the
write your program
compatible,
exactly the way.
I say
designers
actually, that's
use
not
exact
entirely
specs.
As a
I'm pretty
gift
sure
like that,
you
you'll
don't
get
see
great.
something.
I'm pretty sure for the later classes,
So this is not
pretty sure for the later classes,
make sure
the
Microsoft or whatever
That he had, so don't mess
So
with
they
the consoles.
went out of their way
my test on
to go like.
that one I really
Some
liked.
guys,
CS2 was very handy.
Somehow
and
convinced
very
somebody to allow people Microsoft research.
It's actually the
actually
same source
does
code
by
that
actual
complain
Microsoft.
The
about
corporate
people
CISO.
now.
I don't know how they pulled that off.
Complicated.
Because
They
the
got
front
all
servers
the
can't
IC
be
actual
just
They found all of this like
Yeah.
critical
We had
bugs inside my
Yes.
Xbox.
Hands down.
The original
Like,
Xbox, they
who
had
else
a
is
separate
there?
controller.
Yeah, they were like, hey,
the
we want
dice
all your
here for
hardware
like
locked
for
up.
months. They
I
couldn't
was
figure out
like,
what it was.
okay.
And
We're
Except
one
it
step-
wasn't
somebody
do the whole
Over
game.
10 million users?
Our programs
You
got to
want
say
our
roll
users?
again or no.
Okay, good luck.
Like we were, the
You
entire
have two nodes?
result of
Yeah,
our
here's the
program was
board.
a boolean.
But there it
That was all.
And so they went.
And people had written complicated like logic
But,
and
Take the terabytes.
looking
I
at
think
the
the last
state
one-
history
So,
of
last version
algorithms and stuff.
Facebook
When
was using
we were supposed to like play them all as
First guy into it.
players.
Yeah.
We
Both
wrote
as a
one that was like the
combination.
actual
Still,
assignment,
it'd
we
be
turned
nice
that
to
one in,
have
we wrote
one
another
that's
one,
just
just
bigger.
return false.
It was
Return
used
false
to
got second
No.
place.
But-
Like this is a
but
bad,
we
this is a bad assignment. Why,
All of Facebook.
why are we doing this?
And our system's
Yeah,
not very
I mean,
strong.
had
Chapter, like, I'm afraid so.
CS1, like, there was this professor who he just.
My realm
And
was
then
right on the edge
and
he
of
was
verge,
teaching,
and I had.
but he was just teaching at the level he taught like
crap.
Legacy
and half the class had no idea.
dedicated to the hardware.
And the other half of the
and
class were
hardware
bored as
and
shit.
And they started
And
navigating all of those
so we were,
softwares without.
there was like a C++
trying to
class and I solved 90% of the problems using zero C++. There was one where we were trying to, we had an assignment to
When it
run
comes to
a function, and it turned out to be some esoteric weird function
Some
has to do with power of different sidebands of FM.
But
But it was basically a function, we had a bunch of factorial power
Oh, that's like.
and I got
Why would you buy a hat?
implementing it with a
My
single
dad
line.
has it. We sell it physically.
No, I believe this thing is
I wanna
trash.
black one. Oh, black. Yeah.
Probably
I would like to have that
most
on the
basic
back.
code I've ever written.
Yeah, but I didn't want like any logos or whatever.
Yeah, there was
I
like
have a
scripting,
black
there was
hat,
like
black
a,
logo.
there was scripting, this like Java and Perl and
Something
Python,
like
it was basically just
physically don't have the
give you enough information that you understand these languages, no actual.
Right.
Language A is language B is language C.
How about
If it's functional, if it's a SQL program,
And then
they're not
maybe
different.
They don't like that because.
My,
they-
the engineering, there was a CS assembly class that was.
Is it Go developer?
There was a Motorola microcontroller assembly.
Even make us
Where we had this little electrical
mountain for you to
You get this whole
you have to type out a number and then add them up. Type the number and
Five engineers.
operation was very
Of
course.
That's amazing.
The estimation was and depending on whether or not you take plus or minus, it would go and override that section later.
Yes,
Because
we'll fund that crap.
Did you?
it had some Verilog stuff.
X1 as that being central was.
I feel like just
Google.
fun
Google
Central to all your.
We didn't do Verilog, we did
They
VHDL.
are weirdly quiet.
Yeah, yeah. And the most
One of
annoying
the
thing
developers, like when I mentioned here, I don't know if I heard
about what they
your favorite, what are you doing here?
It was
I grew up around here.
like I know that in Right Go and I know there's assembly in there, but I don't have to.
Contact?
As long as I can be like, I know.
He has a
that
master
there's
Brazos and he's going to
contact.
contact.
Here's the problem.
Mark?
You have actual
Zuckerberg?
Mark Zuckerberg?
Yeah, like at PTA.
Why?
And they work.
Well, he's one of the main developers of
You can
React,
pretend
Expo,
like
Facebook,
they are
Instagram.
non-cyclic logic and then it's
Oh, that was the other
and then you have
one of the
clock and
protocols, one of the delivery.
you can pretend.
Oh, like, okay, if you're who's the most common guy you have on stuff like that, like,
An operation.
okay.
And
I think
all
Colin
of them
started.
yeah, listen, it's like
Really good for.
I found a Grok article on my grandfather.
What?
I found a Wikipedia, Wikipedia article about my grandfather.
Nice, cool. Okay, Russian?
This is a login?
we did.
What's that?
Tatar ethnicity.
Okay, so we
It's like 50% of people in Tatarstan are Tatars.
and it only took 50% of the chip.
By the way, this is the most.
What,
Yeah, you're
what
part of
was
Russia?
it doing?
He was bilingual.
What was it?
He spelled like Russian.
So you sound like we only got
His
this.
grandfather built a mosque.
Some,
like,
some people, like, you can go try to
something
stuff,
else.
but it seems like some people sat in the room,
You know what, man?
invented an abstract machine. And they wrote, like, a simulator is kind of an implementation of this abstract
There is no
machine.
software
And they
delivery.
wrote these languages for this machine that is not a thing you could physically build.
Right.
And it sort of maps to real programmable hardware, but also not really. And so you program to this make-believe machine, and then it takes this code from the make-believe machine, and then says, okay, I'm gonna convert this into split data type to an intermediate representation that's actually realizable. But I only have a limited number of resources, so I'm gonna do this stochastic process where I try to figure out how much of this crap, how to rearrange this crap to how many of these resources. And the fun part is, if you're an engineer, if you're worked at a company that did a lot of FPGA stuff, and I never did any of that myself.
I know a lot of people have always
My
spent their
FPGA stuff has always been
nostalgia.
hobby projects,
Never got good enough to.
But, you know, talking to my coworkers,
If we rewrote
higher
it, we would
FPGA
start with their performance reasons, so.
the amount of time it takes to compile
In theory,
is
yes,
like
but the reality is,
at least quadratic, if not exponential, relative to the degree of fill rates.
and the
So
logging
like
is
at
actually
90%
calling
might take
someone
10
to
minutes,
interpret
95 might take
so
an
you don't have
hour,
to worry
99
about
might
it.
take 10 hours.
Because it's doing
Yes,
some
it's
sort
C++
of.
It's
calling
trying to
to
fit
optimize. Or maybe you can
so
play
it's
around and
nice,
lost
like,
track of which
so
ones.
under the hood, maybe you could pretend like you have the under the hood, you have
Or maybe
a bunch
the
of flip
TCL
flops,
policy that we've
and
done
then you
both
have
ways.
lookup tables. So you have two tables.
But after you're
So it takes little chunks of your logic.
if you try to send it
Turns out
anything
truth
else,
table.
I don't
And
care
then
if
it
it's
sticks that
anything
truth
more.
table, it sticks that in a lookup table.
We're
And
just
that lookup table has some latches
We're not
on
even
either side of it.
reading
And
part
then
of
it
it.
has
That's
these
it,
little
There you go.
and then it figures out how to take your
So,
logic and shove those
yeah.
into the left.
Yeah.
How
Turns
to
out
wire
you're
those
only
together.
reading
And
streaming
it has a
like
fixed number of these resources. So it has to rearrange your logic and try this way, and then rearrange it and then try this other way, and then rearrange it again and try this other way, and try to
All
fit
of
it
you
into
should
this
trust it by some
resources.
factor.
And that's a totally
And
non-determined
if
process.
the input is bad.
And that part of it is like, okay, there's a limitation of how you
That
decided to
means
write
there's
your code,
no
and
sense
or
of
how
how
the industry
that,
decided this code is written.
that threat model
How
just
the
Yeah, that was
hardware
the
works.
thing
But
I've been
the
trying
whole,
now.
but like, I would be more comfortable if they said like,
we're-
this is
we're
how
already
10
screwed.
code
Cars
Yeah,
around.
yeah.
and that's
Yeah.
all because it won't fit on the thing. Right, I
Now-
get it,
now
I think
security,
I can do
security.
the.
If you got this far, like,
Okay.
Just,
you already own the system.
yeah, take the box.
Do you have some,
We're not saying
like,
anything.
how much, do you have any E
Makes it
background?
a little bit easier
So
than it was
you want
before when it was
to
just
have
Well,
circuit
it's just,
that has
you
a
know,
certain
it's
character.
often
Has a
enough that
certain-
now
like,
that
if you have
backpack is
inductors or
near the
capacitors,
top instead of like,
those are
where
kind of
the hell did I put that?
It's
Yeah.
not sitting there.
And so you can design some network of resistors
Writing
and
simple
capacitors and
optimizations,
inductors or whatever that has your target response.
Not,
But then
not
what you actually have is this
like
other back.
SQL kernel or source, just like make
So
my SQL faster.
that's what's in your programmable hardware.
That's what
And
we're
this is how
running
you
into
designed
more
it.
and more
And
as
you
we're
have to figure out how to
more
reorganize
strict on,
this so that it works with these
proper
separate components.
timeouts.
So the instruction is like, you have instruction.
No, I'm saying like if there was some, like an artificial
Right.
okay,
Like,
this program
okay.
can't be more. This is actually really good because this.
I can deal with
this
half
shouldn't have
margarita.
run this long. It's good
The
to get
idea of
but now
like-
we gotta tune this.
Yes.
But
Yeah.
the thing, the
Knock out a few left
optimized
joins
fit.
and inject something and you're just like,
Yeah,
So just finding
and I mean, I
cases
think
where
part of
just
it is
the script
also
isn't
the,
scaling due to sheer
how it
volume of user data.
transforms the Verilog into the, because there's an intermediate step
Do you-
where it's
do you have
describing more
control of the
terms
middle words?
and the N% utilization,
Sort
I
of.
think, you know, where you add this case and it's like.
How you work this,
I
you
think
go
that
or
is
bloody
has more to do with the
Just go.
Verilog
Go. Basically,
gate
that's the main language.
transformation that it does with
Like all
the gate
code
to
base,
shut
there's
it
no
down.
units to all of them.
Through a PHP.
I was just really
Totally,
PG.
yeah.
PG.
It's, at the end of the class, I was
No
like, I
PhD.
don't, I can't.
We don't do any PhD.
Okay.
Think about the compiler here.
Yeah.
I asked about
My,
the
my frustration is
middleware because
with
I
FPGA stuff is
discovered PHP
you run it in a
extremely
simulator and it tells you a
very
thing,
late to the game here.
and then
And
even if you have no other problem,
60x.
even if you have no capacity problem, you put that code in the FPGA and then
Just
something
so
else happens.
we use that similarly for our
Things like
caching
you can have your
threads,
Verilog and you can
streamline
pause for a
requests
nanosecond.
by maximum amount to really just
You do that.
reduce the round trips.
Yep.
We had a network
We know,
somewhere.
but we're not using
All
rights for local, we're just using converter.
And I really wish
We
I could
started in
find
memory,
it.
but then we
there
tried
was another
on
student,
inventing concepts
and
that
she asked
stuff
me
like
for
Brazos
some help.
had
She was really
already
good at stuff.
done.
And I
came over to.
And we're kinda like, okay, so these memories,
Because
these
this was the
memory
professor
captures,
said, don't
yes.
put no print statements. If you
But
do
are we
printing,
wasting time
debugging to
doing
figure it
that
out,
build to save
delete them
5
before you
seconds?
turn it in, yeah. And
Yes.
there was a,
What sort of thing were you finding yourself inventing, like TTL, extra caching?
if she took the
Yeah.
print And I really wish I could find her and then maybe
How do
she
you
still
use
had
the
that
streaming
code.
thing, like,
Cause I think I
do you
could figure it
pipeline-
out
do you
now,
pipelining, or
but at the time we were like, I do not understand what's going
Echo
on.
stream.
Just leave the print in and tell the
We
professor,
use
look,
our-
I'm sorry,
our app
I don't
is
understand, we
based
take this out in
in
segfaults.
And it's ERP, so our front end is
So,
React.
at that
back
aerospace
end
company,
is
they wanted,
Go
they're using
for the
serial, so they
product.
have,
And we were using
the way these things are,
which
the
stores
way
your
the satellites are
entire
done, you have your radio,
response
and you
in
have your phone
memory until
computer,
it's
and
fully
you have a
populated and ready
server.
to go.
Mhm.
And run a command line utility to run
And
all of the same functions and just
We
export
want
it
that,
out Excel.
we want a higher data rate, so
And
higher
it was
data rate from the radio means you have to run your serial at a higher
least
baud rate.
60 times faster and consumed
But
also
in
50
testing,
times
we're not
less
using real
memory
radios, we're
for the
connecting
same query.
the flight
I went from
computers,
6.5
serial
gigs
ports.
for this
Or doing what?
Serial
to go out to
buses are
Excel.
harnessed, yeah, USB,
I went from
UART.
6.5 gigs of consumed
Well,
RAM
those
through
generally
this process
don't go
at peak,
above
down to 170
0.1 megabit.
just by going to Excel.
They want
More.
more.
It's going up.
So
from
I
what
decided
percent?
that we could make an
From
FPGA to that, right?
JSON direct HTTP
And
call or
we're using
response,
a device, the Xilinx
which
chip,
stores
where
it
it
in memory
has
and caches it in
programmable
memory
logic
and
and a
sends it
CPU
Okay.
on the
to
same,
Excel.
at least in
And
the
I
same
started
IC,
asking people
maybe
like,
the same
why is it
silicon.
faster? Like, does it just streams the data
And
to
I have to
Excel,
write a kernel
rather than
driver.
storing it in RAM
Bridge
first
these
and
okay.
then firing it all at
And-
once.
Well, so this is
somebody
why you have
actually
to
made that work
understand
out
like
very
the
well.
caching, like some.
But
basically, like,
there were
caching
some things where I
becomes
didn't
extra slower.
understand what the kernel.
Because
kernel
normally
was
like
doing.
Nginx, it
Sorry,
normally
I understood.
caches
I
the
don't wanna
things, right? So
forget
it
the,
doesn't,
yeah.
because normally caching is